All right, I'm going to look at the camera. So good evening, everybody, and welcome to the Fall 2021 TWed Lightning Talks. This is our regular end of semester celebration of everybody's work. The rules for Lightning Talks are simple, 2 minutes talking about whatever you want to talk. We just ask that you come up here. We're going to change the camera angle here in a second to point to the podium. You just stand kind of center over there. And I guess what we should do is let's honor our remote guest first. Feifei, would you like to go first? And if you could please turn on your video for us, that would be wonderful.
Can you see me?
Or are you just here to listen?
Can you guys see me? I'm not really sure.
We see you now. We see you now. Yes.
Okay, that's great. So yeah, I can. So for semester, I pretty much started. For almost 2 years, I've been working on the table question answering task. We started with given the question and the table, searching for the right cell to answer the question, and then we move forward with another like subtask that's retrieving the table from a large table corpus for given questions. So now basically we're building an end-to-end system that can retrieve the tables plus answer the question. So one demo paper has been submitted to ACL, and another paper is now under submission. Similar technique, a similar task, different techniques with the ACL short paper. Other things. Also, we are now moving forward to the multi-model. Table question answering means that the corpus not only has tables but also have passages, not long, like really long documents, but a trunk of text. So there's 2 data sets that's designed specifically for the multimodal table question answering. One is the HyperQA data set, and the other is the OTTQA data sets, which are now very popular for this community. And if anyone's interested or have any ideas or want to use this type of data sets in their research, please reach forward that I can have a discussion with you. That's pretty much everything.
All right. Thank you, Feifei. I apologize. I didn't say, when you begin your lightning talk, obviously say who you are, but also say who you're working with. And if you want, how long you've been around here, that sort of thing. Sasha, I won't make you go next because you're new to the group and new to lightning talks. So I'll let you listen in on a few lightning talks to kind of get the feel, unless you're ready to go, but I won't put you on the spot yet. We actually have a few people who actually signed up. And Sola's next. Sola, would you like to go?
So you want me up at the podium?
Yeah, I'll make it go to the pre-programmed location. You want me to get rid of Jim and Bernie, or are they okay?
I think they can hang out with me.
Okay.
Okay, so hello, my name is Sola Shirai, and I've been working with Deborah for, I'm on my 3rd year now. So that's where I'm at for working towards my PhD. And so today what I would like to talk about is this idea of context as it relates to semantic web technologies, and particularly knowledge graphs. The idea of context, as we use it colloquially, clearly is of some level of importance to help kind of understand either the environment we're in or the information that we're working with. But in actual research related to the semantic web technologies, it's often used very loosely, or on the other hand, it's defined, but it's defined in a very restricted way that's not really usable by other systems, or it's not really easily extendable. And so what I've been exploring is kind of how might we be able to define this idea of context and represent it in some sort of way that works nicely together with the semantic web. And related to this, I'd also like to share 2 ideas that I've been thinking of related to this idea of context. The first is the difference between static and dynamic context. So static context is what I think of for information that you can kind of define beforehand that perhaps defines the environment or a particular system that you're working in that stays unchanged over time. On the other hand, the idea of dynamic context perhaps could be useful to consider information that is contextually relevant that changes over, say, the same run of a particular system or as information that you have available changes. And the second idea about context that I'd like to think about is related to useful and interesting information from the context. Instead of just grabbing everything that's connected throughout a knowledge graph and saying, oh, this is context, here you go, do whatever you want with it, maybe we also should be trying to actually identify which pieces of this connected information through the knowledge graph is actually useful for performing whatever task you're doing, and what is actually interesting, what is maybe surprising to people, what is interesting in terms of actually helping to understand the information they have available a little bit better. So that's all I have to share for now, and it's very much a work in progress in terms of how to actually do those things like defining and representing context. But hopefully I'll have some interesting updates about this line of work down the line. Thank you.
Great, thank you so much. Jim, I hope you don't mind the.
Yeah, I noticed it, John. But that's okay. You might still have a job tomorrow if it's not there by the end of the meeting.
So good evening, everyone. So I'm Jason. I'm a PhD student working with Professor Deborah McGinnis. So I'm going to do my candidacy talk next Friday. I will send out a formal announcement shortly. So today I'm going to talk a little bit about my thesis work, which the title of it is Natural Language Understanding with Semantic Parsing. So natural language understanding is a subfield of natural language processing. So NLU for short. So the main task of this topic is to transforming natural language text into a machine understandable format. So the core task of NLU is semantic parsing, which is also trying to convert the natural language text into a logical forms, specifically, the semantic representations. So those representations can include logical forms or meaning representations or some actual executable programs. So we are trying to we evaluate our approach in three sub-areas. So the first sub-area is knowledge graph question answering. Specifically, we are trying to answer natural language questions using the knowledge graphs. So we are trying to apply the semantic parsing techniques to generate some intermediate representations like semantic query graph to help the generation of the final executable Sparkle queries. So the second sub-areas we are going to tackle is the math word problem solving. What it means is that given a description of a math word problem, we are trying to use one of the semantic parsing, the process called AMR, abstract meaning representation, to help the generation of a mathematical expression that solves the math word problem. So the third sub-area we are trying to evaluate on is a knowledge triple prediction task for a test-based games called Jericho World. So all these subfields are very important natural language understanding sub-areas in the NLP field. So the connection between these three sub-areas is that we're trying to either using some intermediate meaning representations or some existing meaning representations like AMR to help solving the task. So so if you are interested in my thesis work, please come to my candidacy talk next Friday. So see you.
Good luck with that. Thank you. All right, so next we have Jade.
Group here
Oh, okay.
At this Friday.
next Friday.
Oh, next week.
Don't worry, it's a huge number we have to cram.
I won't worry about it. Great. Hi, so my name is Jade. I'm working with Deborah McGinnis. So I'm a second-year PhD student. And I'll be talking about the recent work I've been doing with the fairness metrics ontology. So this was a project which we originally started it over the summer as part of an IBM externship. We continued working on it over the fall semester. And the basic idea is we want to be able to capture all of the fairness metrics and techniques that go into assessing the fairness of a machine learning model. So a lot of these times someone is like, okay, machine learning models are unfair. We know that's a huge deal, but how do you actually analyze the model? How do you actually tell when it's unfair? And there's not one definition of fairness, there's many, and in a lot of cases, they're mutually exclusive. So you can't have more than one definition of fairness be satisfied. So you have to, a lot of work goes into picking what the right fairness definition you want to use is, or figuring out what specific kinds of bias you want to address. And we figured that all of this information can be condensed into a nice, neat package in the form of an ontology. So that was what we did over the summer. And then more recently, we've started working on actually using this ontology together with WIAs. So I've been instantiating some WIAs representation in order to actually represent machine learning model evaluation information and say, okay, this model uploaded at this time, trained on this data set, has these fairness metrics. And then you can use WIAs, of course, very provenance heavy. You can track over time, like, okay, these additional versions have these changes in fairness, and okay, these, other data sets have these different results when you look at the kinds of changes that they make to fairness. And so what we are currently building towards is ideally a way to just analyze the fairness of some machine learning model. So I've been working with Heels, so I've been working with Karen is another student I've been working with, and he has a synthetic data set model, which generates synthetic health data sets. And so the current plan is to use this as an example to see how well does this WIAs-based system work. So that's all been going on for the past couple of months, and hopefully we'll be pretty close to producing something interesting. Yeah.
Thank you. Sabir.
Hi everyone, I'm Sabir Rashid. I'm technically on my 7th year at RPI, but this is my 6th year at the lab. I work with Deborah McGinnis. I'm a PhD candidate here. So my current research relates to different forms of reasoning. But what I'll talk to you guys about today is some earlier work on semantic data dictionaries, but I'll kind of conclude with some future directions that we're focusing on. So what is a semantic data dictionary? So this is an approach developed by our lab for annotating and transforming tabular data into a RDF format. So the semantic data dictionary is made up of several tables. So you have the info sheet, which links all the tables together and allows you to specify metadata about the data set. You have the codebook, which is used to categorize categorical data and numerical values, map them to classes or resources. You have the timeline, which allows you to kind of more explicitly map time series data. And you have code mappings, which allows you to create shortcuts within your annotations. So if you have like units, instead of looking up for the URI for meters, you can just go M and then have all the units mapped already. And then finally, you have the dictionary mapping table, which is kind of like the bread and butter of the semantic data dictionary, which allows you to actually create mappings for both the columns within the data set as well as implicit objects elicited by the data set, or things that the data set refers to, which isn't actually in the data set necessarily. So one of the benefits of this approach is this ability to annotate implicit objects, but also because the annotator is filling out tables rather than, say, doing some kind of programming or writing RDF to do these mappings like earlier approaches, then someone familiar or unfamiliar with semantic web technologies or computer science may more easily create these mappings. So some of the future directions that we're working on is to support additional serializations. So I should also mention that our approach supports provenance and name graphs, and we right now we pretty much create nano publications from the data in the form of trig. However, there's other RDF serializations such as N3 or even simpler serialization like Turtle or just RDF XML, which our current mapping tools don't create. We just create kind of this trig file, but someone might want something simpler than having nano publications, for example, which might be hard to traverse, especially if they don't know. So like one of the existing directions we're working on is supporting additional serializations. We're also working on supporting more complex mapping, like graph joins or table joins, or like even aggregates of values. So for example, if you have a column with a first name and a column with the last name, maybe you want to create a mapping to a full name where you aggregate those columns, or if you have numerical values, maybe you want to do some operation on those. And then we're also working on semantic data dictionary editing capabilities. So there's various platforms that support semantic data dictionaries, including YIS and HADATAC and standalone application. So we want to make it easy for the user to actually edit these semantic data dictionaries, which may also include things like using NLP to suggest terms that they might want to use for their mappings. I could keep going, but
you can't.
But so visit Tetherless World /github.io, tetherless.github.io/SDD to see more documentations on semantic data dictionaries. Thank you.
Thank you. All right. Who do we have that's?
Okay.
And then I think Sasha after this. Go ahead.
Hello everyone, I'm Neha Keshan and I'm working with Professor Jim Handler. So today I'm going to talk about the work, how we are trying to use a computer science techniques to solve a cognitive science problem that is for graduate students. So I'll talk in a more broad manner of what we are thinking. It's building a social machine for graduate mobility. That's a bigger thing that we are looking forward to. But the focus of my thesis would be the backbone of this system, which is the knowledge graph, and how we are using that knowledge graph to integrate the siloed, inaccessible data available in structured, unstructured, and semi-structured format on web for marginalized US graduate students in STEM fields, so that they can use this information, either extract it to make a more informed decision. And why is that important is, say, I am a marginalized student, I'm an Indian woman of color in science. So my requirements will be different from someone who is physically challenged. So it has to be a bit more personalized so that it can get more information that I want. And the second important factor here is so that I can connect with people, which I call as a point of reference, who has either gone through a similar pathway that I'm taking or I want to go through, say a career path that I want to choose, and I'm not sure whether that's possible or not. But if I have someone with from a similar background as me who has taken that path, then for me it seems like, okay, that path has been taken and it's attainable. So I can take that path. And if I can connect with that person in some manner and get more information about how the day-to-day life and activities look like for them, then I get more information and I know, okay, whether that 70% of that day-to-day activity is what I like, what I don't like, and it gives me more information to work on and make a much more informed decision. So getting all these information together in harmonized manner and creating a point of reference for people, especially aspirant, current grad students and degree holders is what we are looking forward. And we already have, if you want to know more about this work, you can look into building a social machine for graduate mobility paper and the Institute Demographic Ontology that we published, and it's available online. Thank you.
And it's award-winning, right?
Yes.
Thank you. All right, Sasha, let's try your audio again.
Test. Is it working?
It sounds
No.
perfect. Sounds good.
Okay. Yeah. I did not sign up today for a lightning talk because I'm currently right now with Neha in the stage of carving out the direction for our PhD thesis. And as these have not been yet approved by advisor Jim Handler, I'm not sure whether I should talk about these things.
You can talk about whatever you want to talk about tonight. This is your lightning talks or talks of what you're interested in.
Oh, as I understood, the lightning talk was the talk about my current research direction, and as this is changing, I was assuming that there would be then no topic for me to talk about.
That's okay. That's okay. This is your first time anyways, so well, why don't you, since you're relatively new, why don't you introduce yourself at least?
Sure. Hi. I'm Alexander Latevich. I am just joined the lab this semester, and I work in the advisor Dr. Handler, and currently working with Neha Upadhyay together to carve out a direction for us for the thesis proposal. Prior to that, I was working on the cognitive CogWorks lab with Dr. Wayne Gray on expertise. My recent work there included the examining the underlying assumptions for measures comparing novices and experts. When measuring expertise in complex domains such as Tetris, where the environment is complex and dynamic in the sense that it's changing even without the player's interaction, so that if the player hesitates, it has to be a deliberate choice because the environment will not be the same 1 second afterwards. One is looking for measures how to quantify the differences between novices and experts and how they differ. And one approach is to break the complex domain down into multiple subparts and investigate, or subtasks, and investigate each one of these independently. One such measure could be, for example, to compare the reaction time latency to a new Tetris pieces appearing on the screen, and thus infer the time needed for an expert and novice to decide where to place the Zoid. However, my work indicates, my work that I've done there indicates that these assumptions of equal task between experts and novices do not hold. And if one does compare such measures, one might end up comparing apples and oranges, as although the measures are the same, and one might get results that seem fine, the underlying cognitive tasks that the expert and novices perform qualitatively differ.
All right. Welcome, Sasha. Thank you very much.
Yeah.
You and I should have a chat sometime. About 25 years ago, I built a Tetris auto player for George Sabanko. Do you guys want to say something to the greater world? Not to put you on the spot.
Just that we're really happy that you're all here and surviving through all the challenges of COVID. And I greatly appreciate that we're working together as a community through virtual spaces and masks and all of that. And it's really a privilege to work with bright young minds. It's why we're here, to, explore new ideas together. That's enough.
And I agree with Deborah. And one of the things we will be doing, exactly the mechanisms she and I are just starting to really get our act together to figure out, is starting to think a little further out about what the future of the Tetherless World Constellation is, how we want to see the research go. A couple of our current big projects will be ending, and we're looking at what may be some of the new directions we want to go in. So stay tuned for a lot of listening on that and hearing what's happening. And it should be an exciting time. We're hoping we can begin to reoccupy this building more than this relatively occasional way we're doing now, and really start rebuilding community a little bit down here and see where we can get to.
All righty. And with that, thank you very much, everybody.
Do we want to offer staff, Enrique or Sam, you want to say anything?
I'm good. I think I'm okay as well.
John, you want to say something?
I always want to say something. I don't have enough time. No, just thank you, everybody. And, as we look, we're coming to the end of the term, and it's, always a stressful time. So stay healthy. And then as we're looking forward, even with, all this doom and gloom about Omicron and the other variants that'll show up, the other Greek letters, just stay healthy. And we hope that we'll be seeing much more of each other in person in the coming term. All righty. Thank you, and have a great end of term. Thank you, Sasha. Thank you, Feifei.
Yes.
Thank you, Sasha, for fixing your audio.
Yes, I just switched the entire machine out, yes. I just have a quick question for Dr. Handler. Dr. Handler, do you have perhaps just a brief moment on your WebEx tonight sometime, or to talk?
Sure.
Sasha wants to know if you can talk on your WebEx to him
Yes.
sometime this evening.
As soon as this is over, I'll go up to my office and turn it on, Sasha. That work?
Okay, thank you so much. Yes, thank you.
All righty. I hope that got recorded.